In summary, our steering system weight will be about 8.4 pounds. Our estimated cost is about $760. Doing our toe change from -1 inch to 1 inch bump, we obtain an overall 0.2 degrees. We will be using a 1/2 inch diameter tubing, and the length will be approximately 16.8 inches. With this in mind, I would like to introduce Greg Miller. He will talk about kinetics.
Thank you, Carlos. My name is Greg Mueller, and I'll be speaking about the suspension kinetics. Our overall design, as stated in the PDR, does incorporate rising rate suspension. This was analyzed using Cosmos motion. We have a natural frequency this year for the front of 2.7 hertz and the rear 2.3. A wheel rate of 88.2 pounds per inch and the rear 74.8 pounds per inch. And a motion ratio in the front of 0.72 and in the rear of 0.68. Our kinetics goals, again, were to improve reliability and to reduce braking nosedive. The features of the suspension: the squat under full acceleration on the rear is 0.62 inches. Keep in mind that the suspension has a travel up and down of 1 inch, so that is within our range. Dive under full braking on the front is 0.81 inches, which means it won't bottom out. Lift under full braking on the rear is 0.95 inches, which will keep the wheels on turn up. The suspension rate will rise in the front from about 81.9 pounds per inch to 94.4 pounds per inch, and in the rear it rises from 68.8 pounds per inch to 82.2 pounds per inch. Again, we are did analyze a number of our suspension components that are going to be manufactured in-house. These are a few examples of the parts. These next few are summarized in the table here. Are all made of 6061 T6 aluminum. The weights vary from less than ½ pound to, well, actually, less than ½ pound. Anyway, the factors of safety are all above 1.25, which was our minimum factor of safety. Our front sway bar will be made from a 4130 heat-treated steel, manufactured in-house. It has an adjustability feature whereby the blade can rotate by 90 degrees, which allows a different stiffness because of the flat-sidedness of the beam structure. This provides a roll stiffness of 381 inch-pounds per degree. The rear sway bar provides a roll stiffness addition of 853 inch-pounds per degree. It weighs just under a pound, has a factor of safety of 1.5, also manufactured out of alloy steel in-house. Our roll stiffness without sway bars, 3,763 inch-pounds per degree, which provided a roll rate of 1.38 degrees per G. When adding in the sway bars, our roll stiffness increased to 4,998 inch-pounds per degree and achieved a roll rate of only 1.15 degrees per G. Our push rods, front and rear, are slender members. Therefore, the critical buckling load is the most important factor. These were calculated in the front to be 1,018.4 pounds and provided a factor of safety of 1.27. In the rear, a factor of safety of 2.5 with a load of 3,019.7 pounds. Again, this year we'll be using the Cane Creek four-way adjustable shocks with the high and low speed compression and high and low speed rebound adjustments. These are specially modified valving for Formula SAE vehicles. They each weigh less than 2 pounds and they cost just under $600 per shock. Additional adjustability feature will be the springs. We have a spring kit. Currently we'll be running 175 pound per inch spring rate in the front and 150 pound per inch spring rate in the rear, but through our extensive tuning schedule, we'll be probably playing around with that too. See how the drivers like that. So in summary, the kinetics will still incorporate the rising rate suspension, belt cranks being a key portion of that, analyzed and verified with Cosmos motion. We'll maintain high adjustability by having adjustable shocks and adjustable sway bars. There was a minor increase in weight of less than 1% due to the chassis change and the push rods being just slightly longer. And at this point, I'd like to turn over the unsprung mass portion of our presentation to Karina.
I just want to go over the unsprung mass for you. Our major redesign was, again, the front and the rear uprights. And while we have come to a very basic design that we like, we'll be adjusting these a little bit in the next couple weeks during design for manufacturing. And the other changes that we have made are very minor. So for the unsprung mass goals from CDR, we want to decrease the unsprung weight, increase adjustability, ease of manufacturing, and increase the overall rigidity. We were seeing a little bit too much deflection in the rear upright, so that was the major cause of why we wanted to make this change. So for the rear uprights, you can see here, this is the model that we've been using, and we have been able to decrease the deflection to about 0.02 of an inch, and also achieve a stress factor safety a little bit higher on purpose than our minimum at 1.3. We have a total weight of 1.5 pounds, and it is going to be slightly easier to manufacture. We are getting rid of the 4th axis machining we had last year by using some detachable brackets you can see here. And the same goes for the front upright analysis. Went ahead and checked out the deflection and factor of safety, again at a minimum of 1.25, which is ideal for us, with very low weight of 1.02 pounds, which is not very much more than it was last year as well. And again, we're going to try and get rid of the 4th axis machining here and just use some detachable brackets as well. These are going to be probably manipulated a little more during the next couple of weeks from what you see here. And the front spindle analysis, we're going to use the same spindles as last year. These proved to be reliable, so we have a stress factor safety of 1.3 and then a fatigue factor safety of 1.13, so we do not expect these parts to fail under our loading. And the same goes for the front hub analysis, which is very high stress factor safety, 4.6. This will probably be adjusted maybe in the future, but for us, we didn't want to, again, make any major changes to this component, so we'll be using this as well. We don't expect this to fail either. And then for the wheels, we chose the Kaiser wheels this year. They do come in the 4-bolt pattern that we're looking for. And there were a couple major reasons, one of which is that we could make a 1 pound static weight savings per wheel this year. And because we knew we were probably going to increase the weight of the uprights, which we have, we wanted to definitely try and make a decrease in weight here. And for the tires, again, we're going to be using the Goodyear tires, D2692 slicks, and these are 9-pound tire weights apiece. We're also hoping that these tires are going to help us achieve the tire temperature that we have desirable this year. And then the bearings, we're going to be using the same bearings as last year as well. So we have typical roller bearings, and you can see the dimensions here. Overall, we purchased most of the parts for the unsprung mass. These will be the Kaiser wheels, Goodyear tires. We have the hub mounting spacer, lock nut, and the wheel studs, and the bearings for the front and rear. So for the summary, we have a total weight this year of 80 pounds, which is 2 pounds higher than last year. So we weren't able to decrease the weight overall, but that could change again. We have all joints in double shear, and we were able to increase the rigidity and reduce the deflection and improve the ease of manufacturing. So speaking of manufacturing, we've given ourselves a schedule here of 2 weeks for design for manufacturing. We also have 87 days allowable for manufacturing, and then assembly starts a month later. So we've given ourselves some leeway to account for some of the problems we might encounter here. We do expect to have everything done by the team completion date that we've set for ourselves. And the total projected cost this year is going to be about $6,700 from what we can figure right now, even with the increased cost of the Kaiser wheels, which we are expecting. So for summary, we do expect our suspension system to at least maintain some of the great performance that we had from last year's car, even with the small adjustments that we've had to make this year. We have non-parallel and equal length double wishbone suspension. We have a 4-way independent adjustable dampers, a modified racket union steering system, and stiffer, still adjustable 6061 T6 aluminum manufactured upright. So for a total cost, $6,700 and a total weight of 112 pounds, which is about a 2% weight increase from last year, but is still 4 pounds under our given departmental weight. And with that, I would like to turn the floor over to Charles.